them all out and then add them together. Okay, so here we see that formula. You'll see it a few ways. Usually you're going to see it this way. Nothing wrong with this. It's just worked out. So if you were to distribute the n and kind of play around with this a little bit, that's where you're going to get the rest of this. No big, or not distribute the n, sorry. Divide around by 2. No big deal. You're going to get the same exact thing. So either one of these works. It's really based on what information you know. So for this one, you would need to know A, N, and D. For this one, you just need to know the first term, the number term you're looking for, and the term of that number. Okay. Whereas in the first, you'd know the common difference. So it just depends on what information you're given. So in part 4, we are asked to find the sum of the first 40 terms. So that means n is 40. And we have our first term here. We don't have the 40th term, but what we do know is a common difference. So if I look at this, I'm adding 4 each time. So d equals 4. So that means we're going to use this first formula because that's the information that we're given. So S sub n is equal to, or actually S sub 40, I should say, is equal to 40 over 2. So this is the sum of the first 40 terms. 2 times the first term, which is A, or 3, plus n minus 1. So we want 40 minus 1 times d, which is 4. And now it's just some arithmetic here. When I work this out, this is going to give us, let's see, 20. That is 6 plus 39 times 4 is 156. So that's going to give us 3,240. And that's the sum of the first 40 terms in the sequence. All right, and the next we want to find the sum of the first 50 odd numbers. So 1, 3, 5, 7, and so on. All right, so that means A is 1. It looks like we're adding 2 each time, so D is 2. And we want N equals 50. So again, we're going to use that same first formula. So we have S of 50 is equal to 50 over 2 times 2 times the first term plus 50 minus 1 times D. All right, so that's going to give us 25. That is 2 plus 49 times 2. Let's see, 49 times 2 is going to give us, 49 times 2 is going to be 98. 98 and 2 is 100. So 25 times 100 is 2,500. Okay. All right. Find the seating capacity of an amphitheater. So this amphitheater has 50 rows of seats with 30 seats in the first, 32 in the second. So 30, 32, 34, and so on. Find the total number of seats. There are 50 seats or 50 rows in total. So really this is just a sequence. We want to add up the first 50 terms in the sequence 30, 32, 34, and so on. So N is 50, A is 30, and it looks like we're adding 2 seats to each row, so D is 2. So we have A sub 50 is going to be equal to N over 2, so 50 over 2, times 2 times the first term, plus N minus 1 times D. All right, so that's 25. That's going to give us 60 plus 98, and that is going to give us, 3,950 seats in total. All right. So we want to find the number of terms in this partial sum. So we want to find n this time. How many terms? That means n equals what? So A is 5. Looks like we're adding 2 each time, so D is 2. This is A sub n, but we don't have n, and that's what we're trying to find. So we could really use whichever formula, but we might as well use the one that uses the D in it. Though we could get away with using the other one. Oh, we don't have a sum, do we? Oh, must be added to get. I'm sorry. I apologize. I misread this. Must be added to get 572. So this is our sum. This is our S sub n. So we have A, we have D, we need N. Okay, so let's use that first formula. So S sub N is equal to, this is N over 2 times 2A plus N minus 1 times D. Okay, so we know the sum. We don't know N, that's what we're trying to find. 2A, so that's 2 times 5 is A, plus N minus 1 times, and D is 2. Okay, got a little bit of arithmetic ahead of us. Let's see. 572. I'm going to multiply both sides by 2, actually. Let's get rid of that 2 on the bottom there. Okay. So let's see. 572 times 2 is going to give us 1144 is equal to N times, that's 10, plus, and let's distribute that, 2N minus 2. Okay. And actually, we could distribute, well, let's clean up a little. 1144 is equal to N times 8 plus 2N. And let's distribute that. So we have 1144 is equal to 8N plus 2N squared. Oh, I think we have a quadratic. So let's see. Let's divide out the 2. Let's get rid of that. That's going to give us back to 572. No big deal. 4N plus N squared. And let's make this equal 0. So we have N squared plus 4N minus 572. Probably not the easiest thing to factor. It's possible, but well, I guess we could. Or we could always use the quadratic formula too. Let's see, 1 plus 1 minus 22, I think, times 26. Let's make the 22 negative. And if not, quadratic formula is perfectly fine here. So N plus 26 equals 0. That gives us negative 26, which just doesn't make any sense. So N minus 22 equals 0. We're going to get N is 22. So the 22nd partial sum should give us that number. And we can always plug it back in to double check.